So let's just talk exponents for a minute. Say that you want to write 64 using a base 2 exponential function. Since 2 to the 6th equals 64, that's a way you could write 64 using base 2. 100 using base 10 is just 10 squared. And if I'm looking for these exponents, since 10 to the third is 1000, that would be 3. And 7 raised to some power equals 7 means that power has to be 1. If you can think about those exponents, you can handle logarithms. Really, a logarithm is just a fancy version of an idea involving exponents. Say you have log base 2 of 8. That expression equals 3. Because the logarithm is just what power you take the base to get what's inside it. So since 2 to the third power, your base on your exponential and your base on your log is 2. If you take that to the third power, you get what's inside of it. The logarithm is just equal to that exponent. Really all a logarithm is. It's the power that you raise the base to get what's inside. Mathematicians just like to make things sound fancy. So we're going to take some logarithmic equations and switch them to exponential equation form. So this is log base 2 of 32, and that is supposed to equal 5. So my exponential function that I'm going to write is going to be base 2. My exponent's going to be 5, and I know that should equal 32. You can check yourself because 2 to the 5th is 32. This one, if I switch to exponential form, needs to be base 10. My exponent's 0, and that should equal the inside. 9 to the first power equals 9. And then log base 1/5 means my base has to be 1/5 on my exponential. If you raise that to the negative second, you get 25. You can go the other direction too. If you have an exponential equation of base 1/5, go ahead and write a logarithmic equation that has base 1/5. You know the log equals the exponent you're raising 1/5 to, and the value inside should be 125. This one's a little bit messy, but the base of my exponential is square root 3. So I'll have log base square root 3 equals my exponent of 4, 9 inside. So let's say you just want to evaluate some logarithms. Log base 3 of 81 equals the power that you take 3 to get 81. You might have to do some guessing and checking in your calculator. 3 to the third is 27. 3 to the fourth gets you 81. So log base 3 of 81 just equals the number 4. Log base 64 of 2 is a little bit weird because you have to try and raise 64 to some power so that it makes it smaller. The only way that's really going to happen is if you use an exponent that is a fraction, because those are like radicals. So if I did some root of 64, I could maybe get 2. Or I could try negative exponents, but that's just going to flip things and make it like 1 over 64. So let's break 64 down. If you break it down all the way, there are 6 factors of 2. So if you think about it, if you were to do the 6th root of 64, that would get you 2, which means, back to switching things to exponent form, 64 to the 1/6 power is equal to 2, since that's the same thing as the 6th root. So our logarithm equals 1/6. These are easier if you switch them to fractions, probably, than if you leave them in decimals. So like 10 to what power gets you 1 over 1000. Think about 10 to the third, because 10 to the third is 1000. If this was 10 to the negative third, that would flip it and make it the 1 over 1000 that we want. So log base 10 of 1/1000 is negative 3. Why don't you guys try this one? There are 2 special kind of logarithms that show up a lot, so they have their own like special names. A common logarithm is a logarithm with a base of 10. If you see one without a base written, your base is automatically 10, kind of like square roots, they don't put the 2 all the time. A natural logarithm is a logarithm with a base of e, so it's written as ln for natural log because it's like German and backwards. This is log base 10 since it wasn't written, so we're looking for 10 to what power gets us 100. Well, that would be 2 because 10 to the second is 100. This is natural log of e to the second. I'm just going to write it as log base e because that's really what it means. So I'm essentially looking for e to what power gets me the inside, which is e squared. Well, if those two things are equal, then that question mark has to be 2. So natural log of e squared is just equal to 2 because that's what power e is being raised to on the inside. Also, they're inverses, so they undo each other. Let's approximate some logarithms. So you can't always get an exact value. Like if I try to do this one, it's looking for 10 to what power gets you 0.85. That's not a whole number, and unless you want to spend guessing and checking a bunch, use a calculator. So I'm just going to Desmos, and under my functions menu, there's a log function. You can type in 0.85, and then you get approximately negative 0.071. You can do this on a regular calculator too. Just hit the log button, make sure you close your parentheses. This is natural log, so I'm looking for e to what power gets me 22. Again, maybe it's 3, maybe it's 4. I'm going to try in Desmos the natural log under the functions menu. So it's approximately 3.09. You could try it and check yourself. If you raise e to that power, you should get around 22. So your logarithm equals approximately 3.091. 3 decimal places is good.